For part 3, we're just going to look at one example, so this should be a fairly quick problem, and we're going to do a composite like usual. There actually really isn't a lot to see here, right? So let's just kind of plan this composite out. So we want to find the composite. Now in this case, this is a composite of a cylinder and a shell. Now let's notice what we're in terms of what we're going to have to do in order to kind of find the surface area of this. So we have the lateral side of the cylinder. We also have the bottom, the base. And then we have the lateral side of the shell. But notice this piece right here. This piece right here, this top base of that cylinder, it's hidden, right? So if you kind of imagine us painting it, we wouldn't be able to paint that red part. So knowing that, let's see what we can do. So as usual, what we want to do is we want to break this up into a couple pieces. We want to break this up into the surface area of the cylinder, and then the surface area of the cone, and then we want to kind of add the different pieces that we have. So let's start with the cone. So for our, let's start with the cone. So remember, for the cone, we don't need the base. All we need is the lateral area. So I'm going to say cone LA, lateral area. So let's see. In order to find the lateral area of a cone, as we know, I'm just going to say the surface area equals pi r L. Now remember, L is the lateral, the slant right there. It's that length. So we need to go and find that piece right there. That is our L. And I'll kind of label that in red. So let's see what we can do here. As usual, we want to see if we can find that right triangle. I think you'd agree we can make a right triangle by dropping our vertical down right there. So this is perpendicular. We already know that this length right here is given to be 28. So we have that piece of the triangle. We also know, I think you'd agree, that if the total height from top to bottom is 90 and the height of the cylinder is 45, then this height right here has to be 45 also, 45 centimeters. Okay? So that's good. So let's go find that slant height by using Pythagorean's theorem. So I'm going to say, let's do this I'll do this in purple. I'm going to say 45 squared plus 28 squared equals L squared. When you solve this, you're going to get L equals 53. So it's actually 53 centimeters. So let's plug this in for our surface area of our lateral surface area of our cone. So we're going to get pi times the radius of the circle, which is 28, times the slant height, which is 53. When we are finished multiplying that together, we get, and let me double check myself here. I get, feel free to double check me, 1484. I'm having a little trouble reading my handwriting. So it's 1484 pi, and of course this is an area, so that's centimeters squared. Okay. We found the cone. Let's go find the cylinder. So the cylinder, right? For our cylinder, reminder on our formula. So remember in order to find the cylinder, it's the perimeter times the height perimeter times height, usually plus a base there, but we don't have a base here. So in this case, what do we want here? So our formula is going to be that, actually, let me just really quickly, because the cylinder, we're also going to find this base right here, right? So we do have one base. So I'm going to say plus the base. So the perimeter is the circumference of that circle. So that is 2 pi r. The h, as we know, is 40. Actually, well, I'm just going to put an h for now. And then our base again is a circle, so that is pi r squared. So let's see what we got. So we have 2 pi times the radius, which is 28, times the height, which is 45, plus pi times 28 squared. Okay? So when we go and do that, when we simplify this, we're going to get 3,304 pi. And of course, that is centimeters squared. And then finally, for our last step, right, we're going to add those two numbers together. So I'm going to be taking 1484 pi plus 3304 pi and adding them together. And when we are finished, you will get 4788 pi centimeters squared. Okay, so again, I think hopefully you will agree there wasn't really anything to see on this composite figure. In fact, it was probably easier than some that we saw in the last section.